Hello everyone, here is Afra Siab. Today we are going to solve IGCSE Physics Paper 4 Theory Extended held on May or June 2019 and paper code is 0625 with variant 43. So let's start from question number 1. Question number 1. Figure 1.1 shows a distance time graph for a cyclist traveling between point P and V on a straight road. So here is a distance time graph in which time is taken on x-axis and it is measured in second, while the distance is taken along y-axis and it is measured in meters. Part A. Describe the motion between point Q and R. So first of all we find the point Q and R on the graph, and Q is this point while R is this point. We have to describe the motion between these 2 points. So on the distance time graph it is a straight line. It means that when body covers distance, its time also increases. Both of these are directly proportional to each other. So we can say that when time passes, body covered equal distance. So here the body is moving with constant speed. So I write here between Q and R, it is moving with constant speed. Second part is R and S. So here is 2 point R and second is S. So we can see that from R to S, the acceleration of body is decreasing. It is a curved path. So we can simply say that with the increase in time, the velocity or speed of body decreasing. So there is deceleration. I write here next point is S and T. So here S is this point while T is this point, and it is a straight line that is parallel to time axis. So here we can see that the time is passes but the distance remains same. The time between 240 and this time is 160. So between 160 second to 240 second, the distance remains same, that is 400, but the time changes from 160 to 240. So here we can simply say that the object is stationary, it is at rest. So that's why the distance is not changing but time passes. I write here stationary object. Part B. Calculate the speed between U and V. Here we have to calculate the speed between 2 points U and V. So the 2 point is, this is U and this is V. As it is a distance time graph, the slope of this graph gives the speed. I write here speed is represented by V and it is equal to slope of distance time graph. And this slope is equal to delta D over delta T. So these are 2 points U and V. We have to find out their corresponding time values and distance values. So by using ruler, I draw the lines. So here we can see that first time is 300 second and at point V the time is 400. So I write here T1 is equal to 300 second while T2 is equal to 400 second. Next we have to find out the value of distance, that is on y-axis. So here we can see that at point V, the distance is 600 meter, while at point U, the distance is 440 meters. So I write here D1 is equal to 440 meters and D2 is equal to 600 meters. Now we have to find out the slope by using this formula. I write here V will be equal to D2 minus D1 over D2 minus D1. So here D2 is 600 minus 440 divided by D2 is 400 minus 300. So the speed comes to be 1.6 meter per second. So between U and V, the speed is 1.6 meter per second. I write here 1.6 meter per second. Part C. After point V, the straight road continues down a steep hill. The cyclist travels down the steep hill. He does not apply the brakes and all air resistance forces are ignored. On figure 1.1, sketch the possible motion for the cyclist after V. So here it does not apply the brakes. It means that it does not come to the rest position. So when he was going down a steep hill, then its height goes on decreasing. I suppose that it's a steep hill and he's moving in this direction. So we can see that the height goes on decreasing. As height decrease, the potential energy also decrease, because potential energy is equal to mgh. It depends upon height. Secondly, when it moves down, then he gains kinetic energy, because loss of potential energy is equal to gain in kinetic energy. So I write here kinetic energy increase, and kinetic energy is equal to half mv square. When kinetic energy increase, velocity also increase. So we can simply say that when it leaves point V and he moves across a steep hill, then he accelerates, or his acceleration goes on increasing. So when acceleration increases, so the curve will be just like this. It shows that the cyclist accelerating. Question number 2. Figure 2.1 is the top view of a small ship of mass 1.2 into 10 to the power 6 kg. The ship is moving slowly sideways at 0.040 meter per second as it comes into dock. So here is a figure 2.1. The ship hits the wooden pillar which moves towards the dock wall. Part A. Calculate the kinetic energy of the ship before it hits the pillar. Here we have to find out the value of kinetic energy when the mass and speed is given. And mass is equal to 1.2 into 10 to the power 6 kg, where speed is equal to 0.040 meter per second. So we have to find out the value of kinetic energy, and kinetic energy is equal to half mv square. It is the formula of kinetic energy. By putting values here, it is 1 over 2 and mass is 1.2 into 10 to the power 6 multiplied by V is 0.040 square. So kinetic energy comes to be 960 joule. I write here 960 joule. The unit of energy is joule. Part B. The ship is in contact with the pillar for 0.30 seconds as it comes to rest. When it comes to rest, it means that its velocity is equal to 0. It is not moving. Calculate the average force exerted on the side of the ship. Here we have to calculate the value of average force, and we know that impulse, that is represented by I, it is equal to change in momentum, and it is also equal to the product of average force and time. So by comparing both of these equations, it comes to be F cross T is equal to delta P, that is change in momentum, and it is equal to the product of mass and change in velocity. Vf is final velocity where Vi is initial velocity. So F will be equal to m Vf minus Vi divided by time t. So here we have to put the values of mass and velocity. So it comes to be F is equal to mass value is 1.2 into 10 की power 6 and final velocity is 0 because it comes to rest. So the initial velocity is 0.040 and time is 0.30. So by solving this, it comes to be F is equal to 1.6 into 10 की power 5. The unit of force is Newton. So it is equal to 1.6 into 10 की power 5 newtons. Next part C. Assume that the kinetic energy calculated in part A is used to do work moving the pillars. Calculate the distance moved by the pillars. Here work is done. It means that we have to use the formula of work, that is the product of force and distance traveled by body. So I write here work done will be equal to force multiplied by distance traveled. Here we have to find out the value of distance, and kinetic energy is used to do work. It means that work is equal to kinetic energy. So I write here the value of kinetic energy and then put the value of force to calculate distance. So D will be equal to W over F, where work done is equal to kinetic energy and it is 960 joule, divided by force is 1.6 into 10 की power 5. So the distance comes to be 0.006 meters. I write here 0.006 meter. Next part D. Dock walls sometimes have the pillars replaced with the rubber car tires. Explain how this reduces the possibility of damage when boat dock. So when the dock topped car tires instead of the pillars, then the time for contact is greater for tire and board as compared to the tire and pillar. When the time of contact is greater, and according to pulse, I is equal to F cross T. When this time is greater, then force will be smaller so that it does not damage. So I write here, as contact time increases, the force decrease. According to and so does the possibility of damage. Question number 3. Figure 3.1 shows a small submarine submerged below the surface of sea. So here is a figure 3.1 and we can see that it's a sea water and it is the surface of sea water and it's the position of submarine. The distance of the submarine from the surface of sea is 3.0 into 10 to the power 3 meters. Part A. The density of sea water is 1030 kg per meter cube. Calculate the pressure due to the sea water on the top of the submarine when it is 3.0 into 10 to the power 3 meters below the surface. Here we have to calculate the value of pressure and pressure is equal to product of density, acceleration due to gravity and height. Here we have to calculate pressure. So put the value of density, that is here rho is 1030 kilogram per meter cube and height is equal to 3.0 into 10 to the power 3 meters. So I write here 1030 multiplied by value of G is 10 and height is 3.0 into 10 to the power 3. So pressure comes to be 3.1 into 10 to the power 7. The unit of pressure is Pascal. So I write here pressure is equal to 3.1 into 10 to the power 7 Pascal. Part B. The submarine emits a pulse of sound to detect other objects in the sea. The speed of sound in sea water is 1500 meters per second and echo is received with a time delay of 0.50 second after the original sound is emitted. Part 1. Calculate the distance between the submarine and the other object. Here we have to calculate the distance and echo is just reflection of sound. If I consider that this is a wall and this is the source of sound that producing the sound. So the source emits the sound and sound travels in this direction and then it is reflected from this wall and come back. If this distance is d, then it comes back. So this distance will be 2d. So here we have to calculate the distance and we know that speed is equal to distance over time. So this distance will be equal to speed multiplied by time and speed is v cross t while the distance is 2d. But here we have to calculate the value of d, so it will be equal to vt over 2. Speed is 1500 multiplied by time is 0.50 divided by 2. So the distance comes to be 380 meters. It means that distance from this point to this point is 380 meters. So I write here distance is equal to 380 meters. Part 2. Another pulse of sound is emitted through the air when the submarine is on the surface. An echo is received from a second object that is in air. The echo is received 0.50 second after the pulse of sound is emitted. Compare the distance of the second object from the submarine with the distance calculated in part B first. Tick one box. Give a reason for your answer. So here we have to tell that either the distance is smaller, same or it is larger. So we know that the speed of sound is less in air as compared to speed of sound in a liquid. I write here speed of sound in air is less than as compared to speed of sound in a liquid. So here the second object is in air. So here speed will be smaller. When the speed is smaller, according to V is equal to d over t, speed is smaller, then the distance also be smaller. So the distance will be small. I tick here. And the reason is that the speed of sound is less in air than liquid. Question number 4, part A. Water molecules escape to the atmosphere from water boiling in pan. Water molecules evaporate from the surface of a bowl of cool water and also escape to the atmosphere. So first of all there is the boiling and second one there is evaporation. State two ways in which boiling is different from evaporation. So we have to differentiate between the boiling and evaporation. Evaporation causes cooling while the boiling does not cause cooling. First point is that evaporation causes cooling while boiling does not. Second point is that the boiling occurs at a specific temperature while the evaporation can occur at all temperature. I write here evaporation occurs at all temperature while boiling occurs at one temperature. Part B. Figure 4.1 shows a heater in metal block. So there is a heater in metal block. The power of the heater is 370 watt and it is switched on for 4.0 minutes. The metal block has a specific heat capacity of 420 joule per kg per degree C and the mass of 5.0 kg. Calculate the increase of temperature of the block. Assume all the thermal energy from the heater is transferred to the block. So here we have to find out the increase in temperature. Here first of all power is given, that is 370 watt and time is 4.0 minutes. Mass is 5.0 kg and specific heat capacity C is 420 joule per kg and degree C. So here we have to calculate the increase in temperature delta T. We know that energy is equal to mc delta T. Here we have to find out the value of delta T. It will be equal to E over mc. But we don't know the value of energy. Mass is also given. C value is 420 joule per kg per degree C. First of all, we have to find out the value of energy and it is equal to the product of power and time. Here power is 370 multiplied by time is 4 minutes. First of all, we convert this time into second by multiplying it with 60. So that energy comes to be 88800 joule. So by putting this value of energy into this equation, we can find out the value of change in temperature. So delta T will be equal to 88800 divided by mass is 5 kg and C is 420. So delta T comes to be 42 degrees C. I write here 42 degrees C. That is the temperature increase. Question number 5. Figure 5.1 shows a cross-section of the inside of vacuum flask containing a cooled liquid. The walls of the vacuum flask are made of glass. So there is a figure 5.1 in which we can see that it's a flask and it contains cold liquid inside this. So there is a stopper and a silvered surface. There is also the vacuum. Part A vacuum flask is being used to keep a liquid cool on hot day. Explain how the labeled figure of vacuum flask keep the liquid cool by reducing thermal energy transfer. Include the names of the processes involved. So we know that heat transfer through three different methods. One is conduction, second one is convection, and radiation. So here we have to keep a liquid cool. That's why we have to reduce the thermal energy transfer. For that we can take different steps. First of all, there is a silver surface and it reduces the heat transfer by radiation because it is a poor absorber of heat. So I write here silver surfaces are poor absorber of heat and they reduce heat transfer by radiation. So there is also vacuum. This vacuum stops the heat transfer by conduction because it lacks any medium. So I write here vacuum stops heat transfer by conduction. Due to the lack of medium. And next there is a stopper that prevents convection. So stopper prevents convection and the glass reduces heat transfer by conduction. Part B. Suggest a suitable material for the stopper. So stopper may be any insulating material just like cork, plastic or rubber. So I write here suitable insulator like cork or plastic. Question number 6, Part A. Figure 6.1 shows wave front of wave approaching a narrow gap and passing through the gap. The wavelength is represented by lambda. So here is a figure 6.1. We can see that these are the wavefront and the direction of this travel is from left to right. And this is the narrow gap between the slits. The wavefront at passing through this gap bent into circular shape. Part 1. State the name of process that occur as the wave passes through the gap. So as the waves bending in the form of circle, so here diffraction involved. I write here diffraction. Part 2. The wave with a wavelength lambda by 2 approaches the same gap. The gap is same, but now the wavelength is half, that is lambda by 2. On figure 6.2, draw 3 wavefronts for this wave as it approaches the gap and 3 more wavefront as the wave continues beyond it. So here we have to draw the 3 wavefront whose wavelength is equal to half of the wavelength that was before. So I write here, I consider that first of all wavelength is lambda and then it becomes half. So here wavelength I represent with lambda prime and it is equal to lambda by 2. So here wavelength is half, and when the wavelength is small as compared to the gap of slit, then the diffraction will be less. So there will be less diffraction as compared to figure 6.1. Now I am drawing wavefronts. Here you can see that the distance between two wavefront, this, it is equal to lambda. But in figure 6.2 we have to half this distance. Now I am going to draw this wave. So this is the first wave. Distance we have to do half, so it will be approximately at this distance. Second wavefront will be this. First of all, I write here the distance between this is equal to lambda by 2 and it is also equal to lambda by 2. When they passes through this gap, they will bend into circular shape. But their bending will be very small as compared to figure 6.1. So it will be so we have to take care that this distance also be equal to lambda by 2. Part B. Table 6.1 shows 5 different types of electromagnetic waves. So first of all, we have to know that what are electromagnetic waves. These are the waves that don't require any medium for their propagation. I write here the wave that do not require any medium for its propagation. So these are electromagnetic waves. In the blank column in table 6.1, write the numbers 1 to 5 to show the order of wavelength. Write 1 for the wave with the shortest wavelength and 5 for the wave with longest wavelength. So in the table there are different kinds of electromagnetic waves that are gamma rays, light, microwaves, ultraviolet and X-rays. So first of all we have to know about the order of these wavelengths, that the shortest wavelength is for gamma rays. I write here 1, and the longest wavelength is for microwaves. Because E is equal to hc over lambda. Here lambda is wavelength, E is energy. So the energy of gamma rays is very large as compared to the all other. That's why its corresponding wavelength is very short, because here E is inversely proportional to lambda. So the longer wavelength means that shorter energy. But here gamma rays is the most energetic, that's why its wavelength is very small. And the microwaves has the largest wavelength because its energy is very small as compared to all other. So secondly, the X-rays has larger wavelength as compared to gamma rays, and after that there is ultraviolet rays, and at the end there is light wave. Part C. State the speed of radio wave in air. Here we have to write the speed of radio wave in air. As the radio wave is electromagnetic, so all of these move with the speed of light. I write here 3 into 10 to the power 8 meter per second, that is the speed of light. Part 2. The radio station transmits radio wave with a frequency of 96 MHz. Here frequency is 96 MHz. Calculate the wavelength of this radio wave. In part 1, the speed of radio wave that is used is 3 into 10 to the power 8 meter per second. We use the same, that V is equal to 3 into 10 to the power 8 meter per second, and frequency is given, that is 96 MHz, and it is equal to 96 into 10 to the power 6 Hz. So here we have to calculate the value of wavelength by using relation that V is equal to F lambda. So lambda is equal to V over F. By putting values of V and frequency, we can get the value of wavelength, and it is equal to 3 into 10 to the power 8 divided by frequency is 96 into 10 to the power 6. So the wavelength comes to be 3.1 meter. I write here 3.1 meters. Question number 7. Figure 7.1 shows light approaching a boundary between two materials at speed v. The speed of light after crossing the boundary is 1.3 v. So here it is given that in this medium speed is v, while when this ray, that is light ray, crosses the boundary, then its speed will be equal to 1.3 v. Part A. Determine the angle of incidence. Here we have to find out the angle of incidence. We can see in a figure 7.1 that the ray of light strikes the boundary at angle 50. So first of all we draw the normal ray at that point, and then we can find out the angle of incidence. So any ray that is at angle 90 to this is normal ray. So it will be just like this. So it is a normal to this surface, and incident angle is the angle that the incident ray make with the normal ray. I write here angle of incidence is the angle that incident ray makes with normal. So here we can see that it is the incident ray while it is the normal ray. So the angle between them is this. This is basically the angle of incidence. I write here I. Now we have to find out the value of angle of incidence. So here this angle is basically 50. The whole angle from this to this is 90. So I write here 90 is equal to 50 plus I. Here we have to find out the value of I. It will be equal to 90 minus 50, and it is 40. So the angle of incidence is equal to 40 degrees. Part B. Calculate the angle of refraction. So here we have to find out the angle of refraction. I write here refractive index that is represented by n. It is equal to sine of angle of incidence over sine of angle of refraction. So here we have to find out the value of r. For that we have to know about n. First of all, n, that is refractive index, it is the ratio of c over v, where c is the speed of light and v is the speed in any medium. So I write here c over v is equal to sine of angle of incidence over sine of angle of refraction. So I separate sine of r, it will be equal to v over c multiplied by sine of I. It is given that first of all speed is equal to v and then it becomes 1.3 v. So I write here v is equal to 1.3 v. This v is basically equal to 1.3 v while c is equal to v. So it will be 1.3 v over v multiplied by sine of 40 degrees. And r will be equal to sine inverse of this v cancels by this. It is 1.3 multiplied by sine of 40 degree. So the angle of refraction comes to be 56.7 degrees and it is almost equal to 57 degrees. I write here angle of refraction is equal to 57 degrees. Question number 8. Figure 8.1 shows a 240 volt main supply connected to an air conditioning unit and a freezer. A fuse X is placed in a circuit as shown. So in figure 8.1 we can see that it's a freezer and it is air conditioning unit and there is also a fuse that is connected in this circuit and the voltage is 240 volt. The freezer has an operating power of 700 watt. Calculate the current in the freezer. Here we have to calculate the current in freezer when power and voltage is given. So using the relation that power is the product of current and voltage, we can find out the value of current. It is equal to P over V, where power is 700 watt and voltage is 240. So the value of current comes to be 2.9 amperes. So this value of current is basically through the freezer. It is 2.9 ampere. I write here current is equal to 2.9 amperes. Part B. The maximum operating current of the air conditioning unit is 7.5. So the current through the air conditioning unit is 7.5. I write here 7.5 amperes. Fuses of rating 1 ampere, 3 ampere, 5 ampere, 10 ampere, 13 ampere and 30 amperes are available. Suggest a suitable rating for fuse X. Give 2 reasons for your answer. Here we have to suggest the suitable rating for the fuse. So going back to the circuit, we can see that there are air conditioner unit and freezer and both of these are connecting parallel. First of all, we have to find out the total value of current passing through the circuit, and this value of current will be the sum of the current through the freezer plus the current that is passing through the air conditioning unit. So I write here total current will be equal to the current through freezer plus current through air conditioning unit. I write here just unit. So it is equal to 2.9 ampere plus 7.5. So that total current comes to be 10.4 ampere. It means that 10.4 ampere is the current that is passing through this whole circuit. So here total current is 10.4 ampere. Now we have to compare this value of current with all of these. So the fuse should have higher value than 10.4, because if the value of fuse current is less than 10.4, the fuse will melt for no reason and the appliance does not work, even current flowing through circuit regularly. So the fuel rating should be greater than 10.4 ampere and it is this value, that is 13 ampere. If I take 10 ampere, then the fuse will melt for no reason. That's why I select 13 ampere, because it is very close to 10.4. So I write here fuse rating is 13 ampere, and the reason one is that the lower rating fuse will melt at normal circumstances, and second point is that the high value fuse was not melt even when current is dangerously high. So going towards the next part, that is part C. A fuse is made out of a short length of wire. Explain why the fuses of higher rating are made for thicker wire. So first of all, I consider a wire here. I consider that it's a wire and the current is flowing through this wire. This wire melts only when the value of current crosses a certain limit, and the current flow through this wire. Because of this current, the resistance will also offer this wire, and the temperature of this wire will increase. As a result, the wire melt and get fused. So when the temperature is larger, this wire melt and get fused. Now if we have a higher rating of current, I suppose that now the value of current is 15 ampere, then we need fuse of rating greater than 15 ampere, and this value of current is associated with a very large in temperature, due to which we need to melt wire at high temperature. But if I consider that we melt the wire at low temperature, this would not work for higher reading. So here we do that, we decrease the resistance by increasing the cross section area or diameter of this. We decrease resistance by increasing area of cross section of this wire, because we know that the resistance is inversely proportional to cross section area, so that when resistance is smaller, then the temperature will be small, and the higher value of current pass through the wire before it get melted. So I write here resistance is inversely proportional to cross section area, which is given by this relation. Thicker wire would have lower resistance and it would melt at higher value of current. Due to less heating effect. Part D. Electrical energy can be obtained from renewable and non-renewable sources of energy. Part 1. State 2. Renewable source of energy. So first of all we have to know about the renewable source of energy. These are the sources that can be used again and again, and we can obtain energy from these sources again and again. So the two renewable sources are actually solar energy and hydroelectric. So I write here solar energy, the energy that we obtain from the solar, and second one is that hydroelectric. Part 2. State one social, economic or environmental disadvantage of one of your answers in part D1. So here we have to describe one of the disadvantage. So the solar panels take up huge areas of land. So I write here solar panels take up huge area of land. Question number 9, part A. Figure 9.1 shows an electrical component. Here is a figure 9.1 and we can see that there is a electrical component and this arrow shows that light is falling on it. State the name of the component shown in figure 9.1. So this component is basically LDR, that is light dependent resistor. So I write here LDR. Part B. In the space below, write on the truth table for NOR gate. Here we have to write the truth table for NOR gate. First of all, we have to know about NOR gate. This gate is combination of OR and NOT gate. So I am going to draw this. Now I am going to write here. First of all, NOR gate has two inputs. If I consider that inputs are A and B, and then Y is the output of NOR gate, then I write here A, B. First of all, this is for X, and this X is basically OR gate. And for A and B, the OR gate is A or B, and Y is NOR gate. When we apply NOT over this, it will be A or B with NOT symbol over it. So I write here Y. The inputs are 0, 0, 0, 1, 1, 0 and 1, 1. So first of all, we have to find out the value of X, and X is basically OR gate. In OR gate, the output is high when any one of the input is high. High means 1 and low means 0. I write here 0 for low and 1 is for high. In OR gate, when any one of the input is high, the output will be high. So first combination is 0, 0. Both of the inputs are low, the output will be low. Second combination is 0 and 1. It means that 1 is high, so the output will be 1. Here is also 1, 0, 1 is high, that's why the output is high. And in the last combination, the inputs are 1 and 1. Both of these inputs are high, then the output will be high. And here Y is basically for NOR gate when we apply NOT over OR. So I have to apply NOT over X. In NOT gate, we just invert. It means that we convert 0 into 1 and 1 into 0. So I write here 1, 0, 0 and 0. This is a complete truth table for a NOR gate. Going towards the next part. Part C. Figure 9.2 shows the connections between two logic gates. So in the figure 9.2 we can see that these are the two logic gates. This gate is NAND gate, that is the combination of AND and NOT, and this is OR gate. Complete the truth table shown in table 9.1 for this combination of logic gate. Here we have to complete the truth table. We can see that inputs are A, B and C, while the output is E, and there is an intermediate point that is D, which is the output of A and B when we apply NAND over it. So first of all, I am going to draw the truth table for NAND and then we move forward. So first of all, it is the truth table for NAND gate. Now I write here inputs are, I suppose that inputs are X and Y and the output is Z. There is also a point, I let's suppose that it is equal to M. So the inputs are 0, 0, 0, 1, 1, 0 and 1, 1. This M is basically for AND gate, and AND is equal to X and Y. In the AND gate, the output is only high when both of the inputs are high, otherwise it is low. So in the first combination it is 0, 0, that means the inputs are low, the output should be low, it is equal to 0. And second 0, 1, here is one high input, but in the AND gate we require both inputs high. So these two combination also equal to 0 and the last combination is high because the both inputs are high. And here Z is the NAND gate when we apply NOT over AND. So it will change 0 into 1 and 1 into 0. So I write here 1, 1, 1 and 0. So now going back to this table 9.1, we have to write the column for D. So first of all, we can see in this figure that D is the output of NAND gate. So there is 0 and 1. So 0, 1 here is this, the output is high. So I write here first of all it is equal to 1. Secondly it is 1 and 0. So it is 1 and 0, the output is again high. So I write here 1. Third one combination is 1 and 1. In this truth table you can see that it is 1 and it is 1, but the output is low. So I write here 0. In the last combination it is again 1 and 1, so the output will be 0. Now the output E. Going back to the figure, we can see that the output E is basically the output of R when we are D and C inputs. So this is C and this is D. When we apply OR gate, I suppose that here I am going to apply OR gate. So when both of the inputs are low, output will be low. When any one of the input is high, the output will be high. So in all this combination, it is equal to high because at least one input is high. So we are going to fill this table according to this. So here input is 1 and 1. So it is 1 and 1. The output is again 1. I write here 1. Second input is 1 and 1. The output is again 1. Third one is 0 and 0. We can see that it is 0 and 0. The output is 0. So it will be equal to 0. And the last one combination 1 and 0. Here it is 1 and this is 0. So it is equal to 1. So I write here it is equal to 1. Part D. Referring to a simple electron model, state distinguish electrical conductors from electrical insulator. So here we have to differentiate between the conductors and insulators. We know that in electrical conductors there are large number of free electrons as compared to insulators. So I write here conductors have free electrons. As compared to insulators because insulators do not have free electron. Question number 10. Figure 10.1 shows a simple alternating current generator. There is a figure 10.1 and it is alternating current generator. There is a magnetic field that is provided by this north and south pole and there is a coil that is placed inside this magnetic field. And there are two things that is P and Q and the output is taken along these terminals. Part A. On figure 10.2, sketch a graph to show how the electromotive force, that is EMF induced, varies with time for one revolution of coil. Assume that the coil starts in the horizontal position as shown in figure 10.1. So this position is basically the horizontal position of coil. Label the point on the time axis where the coil has completed 1/4th revolution and 3/4th revolution. So going back to the diagram 10.1, we can see there is a south and north pole and the coil is placed inside them. At this position the coil is horizontal, so it cuts the maximum magnetic field lines. So I write here in horizontal position coil cuts maximum number of magnetic field lines. As a result, flux changes because phi, that is flux, it is equal to B dot A. So the flux changes and there will be the induced EMF and the induced EMF will be maximum. So the induced EMF that is represented by E, it will be maximum because the maximum number of lines are cutting the coil. Second thing is that when 1/4th rotation complete, then this coil comes in vertical position. And in vertical position, the coil cuts no magnetic lines of force. That's why the flux will be equal to 0 and the EMF will be minimum. So I write here no cutting of magnetic field lines, that is represented by B, so that the flux is equal to 0. As a result, EMF is also equal to 0. So after half cycle, when the coil is again in horizontal position but their sides are changed, so again the coil is in horizontal position, so there will be the maximum number of cutting of magnetic lines of force, so that the flux is maximum and EMF is also maximum. But position when 3/4 cycle completes, then again it will be in vertical position, so there will be zero flux and there will be EMF 0. But again when one cycle complete, it is again in horizontal position and the maximum number of lines cutting there, so that EMF will be equal to maximum. So we have to draw its motion on figure 1.2. So first of all, in this horizontal position, we see that the EMF is maximum. So this is the maximum point while this is minimum point 0. So first of all, when coil is horizontal, the flux is maximum. That's why the EMF is also maximum. So when I draw the curve, it will be just like this. This is 1/4, while at this position it is half, and this is 3/4, and at this position one cycle completes. So we also have label 1/4 and 3/4 at this point. It is 1/4 rotation and this is 3/4 rotation. At this point the EMF is equal to 0 because at this position the coil is in vertical position. So moving towards the next part, explain why the EMF is induced in the coil when the coil is turning. So when the coil turns, then there will be the cutting of magnetic lines of force. That's why there will be the induced EMF. So I write here, coil cuts magnetic lines while turning. So when there is cutting of magnetic lines, so there will be the flux that is represented by phi, and as a result of this flux there will be the induced EMF that is represented by E or EMF. So next part is C. State the name of the component labeled P and Q and state their purpose. Here we have to give the name of this component and also describe for which purpose it is used. So going back to the diagram, we can see that there are P and Q 2 points. This one is P while this is Q. So this is basically the slip rings. So I write here the name of this is slip rings. And the purpose of these slip rings is to provide continuous connection while coil rotates. Provides continuous connection when coil rotates. Part D. State two possible changes that can cause a larger EMF to be induced. So we have to describe the two changes that causes the EMF to increase. So that first of all we have to increase the strength of magnetic field. So I write here increase the strength of magnetic field. And second change is that we have to move the coil faster. So when we increase its speed, there will be the larger EMF induced. I write here increasing speed of coil rotating. Coil rotation. So that there will be the maximum EMF induced. Question number 11, part A. Americium Am is a radioactive isotope. A nucleus of americium contains 95 protons and 146 neutrons. So it contains 95 protons and 146 neutrons. It decays by emitting an alpha particle to form a nucleus of an isotope of neptunium Np. Write down the nuclide equation for the decay of Am. 2Np. So here we have to write out the nuclide equation, and as it goes alpha decays, so the atomic number decreases by 2 while the mass number decreases by 4. So first of all I write Am, and the number of protons is 95. Number of protons is equal to atomic number. So atomic number will be equal to 95. I write here 95. And it has 146 neutrons. So the mass number will be equal to sum of number of protons, that is atomic number, plus number of neutrons. It will be 95 plus 146 and it is 241. So I write here 241. This element undergoes alpha decays, and alpha decays are helium nuclei with atomic number 2 and atomic mass is 4. So the new element is Np. We have to find out its atomic number and mass number. For that we check atomic number and mass number on both sides of this arrow and balance them. So first of all atomic number, on left hand side it is 95 and on right hand side it is 2. So which number we have to add here so that it becomes equal to 95? It is 93. Then both of these are equal. So I write here 93. Now I am going to check the mass number. It is equal to, on left hand side it is 241 and on right hand side it is 4. So I add 237, then it becomes 241. I write here 237. So it is a complete nuclide equation for this decay. Part B. Ionization smoke. Detectors contain americium and two small electrodes with a small voltage between them. The air between the electrode is ionized by alpha particles so that there is a small electric current between the electrodes. Part 1. Suggest and explain the effect of smoke on the current between the electrodes in the smoke detector. So we have to explain the effect of the smoke on the current, that either it increase, decrease or remain same. So first of all, in a smoke detector, the current decreases. I write here current decrease because when smoke enters, its particle get ionized, disrupting between both electrodes continuously so that the value of current decreases. I write here current decreases and the explanation is that current get disrupted or stopped because alpha particles get absorbed by smoke. Alpha particles get absorbed by smoke. In suggestion, we can also write that current gets stopped. Our current gets stopped. Part 2. Suggest 2 reasons for using an alpha particle emitter in smoke detector. So we use the alpha particle in smoke detector because it travels very short distance. First, it travels very short distance. I write here. They travel very short distance. And second reason is that alpha particles have very strong ionization. So I write here alpha particles have very strong ionization energy. So that's why we use the alpha particles emitter in smoke detector.